Welcome back to our session on measuring information transfer in complex systems. In this short video, we're going to look at various interpretations of the measure of the transfer entropy that we just introduced in our last short video. First of all, let's think about the role of the conditioning on the history, the past of the target in our measurement. What is it? What is the meaning of that conditioning that changes a time lag mutual information from the source to the target to a conditional mutual information between those two conditioning on the target past? The first thing I would say is that this provides us a contrast to the information storage, a contrast to the measure of active information storage that we looked at in our previous session. First, that contrast removes any information storage from being considered as transfer. That conditioning on the past of the target is specifically conditioning on the information source that we looked at as the source of our storage. So what this conditioning is doing is it's removing any redundantly held information that's held redundantly between the past of the target and the source from being considered as information transfer here. We can see this mathematically if we look at this information regression of the uncertainty of the target variable being the sum of information from the target past, that is the active information storage term, plus a conditional mutual information from a source given what we've already seen from the past in the context of what we've seen from the past, plus remaining uncertainty. Now the fact that we have active information storage plus transfer entropy here means they're complementary terms in this regression of the information in the target. Because they're complementary terms here, mathematically, we are not double counting. And it's the conditioning on the target past that makes sure that we are not double counting. So one way I like to think about this is that information transfer is defined in juxtaposition to storage. It's given its meaning in contrast to information storage in our model. Okay? It's a very important concept to understand. It's specifically defined the way it is to contrast with information storage when we're modeling both in our wider perspective of information processing in complex systems. Importantly, we've made a principled choice here to have a first step in our modeling process of looking at the information storage and a second step to looking at the information transfer, considering the storage first and then the transfer as a principled choice to align with the way we typically describe the dynamics of variables in complex systems by starting with the past to understand that state update and then looking at sources. Another interpretation here is that the transfer entropy examines state transitions in the target. Recall from our previous session, we interpreted these past vectors, these as Tarkin's embeddings of the underlying state of the target. Okay, so here what we're actually doing is examining a state transition from that past vector to the next value. Or we can think about including redundant information in the next value and think about a transition between two embedded states in the target. So here we can think about the transfer entropy as the information provided by the source about this dynamic state transition in the target. Okay? A third way we can interpret the role of conditioning for the transfer entropy is that to think that the transfer entropy examines the contribution from the source in the context of the target history. Now, to a large degree, that's similar to what I said a couple of slides ago. But I want to make explicit that the target past, its role here in the conditional mutual information is not only to condition out redundantly held information between the source and the target past, but that it allows the transfer entropy to include synergies, synergistic information or complementary information from the source and the target past together. Remember, that's one difference that the conditional mutual information has to the unconditional mutual information. The conditioning can act to increase the information that we see. We're having here an understanding of the past state of the target allows us to understand the influence of the source allows us to decode that influence of the source. This was labelled as a state-dependent component of information transfer by Williams and Beer. A simple example here is if we have an exclusive OR operation occurring between our source and our target past in generating the target next state. If we just looked at a mutual information from the source to the target next state, we wouldn't see an interaction. If we condition now on the target past, we will be able to identify this effect from the source in the context of the target's past. So to understand here what's going on, we can think about our modeling process again as including the target past in order to give us context to consider the other sources. Okay? In a similar vein, I just want to touch on the partial information decomposition, which I mentioned very briefly earlier in our course when we were thinking about the conditional mutual information and how it was different to the unconditioned version. And I mentioned how this was a very hot area in contemporary information theory, which tries to consider, when we think about the information that one source, M, has about a target variable X, and a source Y has about a target variable X, we can think about how they have something held redundantly or in common, something each holds uniquely, and something that you can only see when you put those sources together. So in the outer oval here, this is the joint information from the two sources about the target, and we get something extra that we can't get from either source alone, and that's called the synergistic or complementary information component. Now, as I said, this is a very hot area in contemporary information theory. There's a lot of debate about what the right measure to use is. As I think I've mentioned earlier, I think my PhD student Connor Finn has found the right approach for that, but that's still a subject of debate in the community. Regardless of which measure you use, people certainly believe that these components are there. If we try to break down the joint effect of the past embedded state of the source, which we can represent by variable M in our diagram here, and then look at, the past embedded state of the target as variable M, and then the source Y here. If we try and break down how they interact to provide information about the next value of the target, we can look at an information decomposition, and we can say here in this diagram, the white part here is the active information storage, the mutual information from the past state labeled M about the next value, and we can look at the transfer entropy as what's shaded in green here. The information storage component includes the redundant piece that's redundantly held by the past value and the source value plus a unique component from the past. The transfer entropy includes a unique component from the source plus a synergistic component. Now we could switch our ordering and consider the source first and then the target past, and that would flip some of the diagram here. We would then consider all of what's inside here as our information transfer, and what's in this unique component, the synergy, as our storage. But doing it in that opposite ordering doesn't align with how we naturally break down storage and transfer in looking at complex systems. We naturally look at storage first, and that's why our storage term is going to include the redundant piece here. We naturally start our regression with the target past and then move on to the sources. Okay, that's why we're taking the ordering the way that we are here, because that's normally the way people model the dynamics of information processing in complex systems, by starting with storage first. Okay, that's why we make this principled choice here. In our next short video, we'll continue exploring interpretations of transfer entropy, this time contrasting the concepts of information transfer and causal effect.